Ever wondered why pushing a door at the edge is easier than pushing near the hinge? Or how a tiny wrench can loosen a giant bolt? The secret is moment of force, the hidden physics behind turning power. Let's break it down. Moment of force is also called moment or torque. Moment of force is defined as the turning effect of a force about a pivot. It is also defined as the product of force and perpendicular distance from its point of action. The moment of a force depends on the size of the force applied and distance from where it is applied to the pivot. The larger the force applied, or the longer the distance from the pivot, the greater the turning effect. Note that the moment of force only occurs when the force is applied at a right angle and a distance away from the pivot. For instance, if this end is the pivot of the object and this is its distance, the object can turn if force is applied at a right angle and a distance away from the pivot. But if force is applied parallel to the distance from the pivot, the object cannot turn, and the moment of force is zero. Did you know the Great Pyramids of Egypt were likely built using the principle of moments? Ancient engineers used levers and counterweights to lift heavy stones, applying forces at the right distances to maximize their turning effect. Moment of force is mathematically expressed as moment of force is equal to force times distance, or simply m is equal to F times d. Now the principle of moments. The principle of moments states that for an object to be in rotational equilibrium, the sum of clockwise moments must be equal to the sum of anticlockwise moments. At equilibrium, the total clockwise moments is equal to total anticlockwise moments. The principle of moments is mathematically expressed as F1 d1 is equal to F2 d2, where F1 and d1 are clockwise force and distance, and F2 and d2 are anticlockwise force and distance. Try this. Take a ruler and balance it on your finger. Now place a coin on one side. Can you move your finger to keep it balanced? That's the principle of moments in action. Try different positions and see how it changes. Both the moment of force and the principle of moment have several applications. The following are the applications of the moment of force. Wrenches and spanners. When using a wrench to tighten or loosen a bolt, applying a force at the end of the wrench increases the moment of force, making it easier to turn the bolt. Door handles. Door handles are placed far from the hinge to maximize the distance from the pivot point, making it easier to open or close the door with less force. Levers. In simple machines like levers, the moment of force is used to lift heavy loads by applying a smaller force at a greater distance from the pivot. Steering wheels. The large diameter of a steering wheel allows a driver to apply a small force to create a significant moment of force, making it easier to turn the wheels of the vehicle. The following are the applications of principles of moment. Balancing beams. In construction, the principle of moment ensures that beams and other structural elements are in rotational equilibrium to prevent tipping and ensure stability. Bridge design. Engineers use the principle of moment to design bridges, ensuring that the moments from different loads such as vehicles, wind, and so on are balanced for structural integrity. Scales and balances. Traditional balance scales use the principle of moment to measure mass. Equal moments on both sides of the pivot ensure the scale is balanced, indicating equal masses. Crane operations. Cranes use the principle of moment to lift heavy loads safely. The counterweights balance the moments created by the load, preventing the crane from tipping over. And finally, architecture. Architects apply the principle of moment when designing buildings to ensure they remain stable under various loads, including wind and earthquakes. Now let's consider some examples. The image depicts the moment of force. If 50 newtons is applied 2 meters from the pivot, what is the moment of force? Moment is equal to force times distance. The force given is 50 newtons, and the distance is 2 meters. 50 times 2 gives 100 newton meters as the moment of force. The second example, if the moment is 30 newton meters, calculate the force applied. Force is equal to moment over distance. The moment given is 30, and the distance from the image is 0.6. 30 over 0.6 gives 50 newtons as the force applied. The third example, calculate the distance x needed to balance the seesaw in the image. The formula for the principle of moment is F1 d1 is equal to F2 d2. As we need to calculate the distance x, the formula becomes d2 is equal to F1 d1 over F2. d2 is x, F1 is 70, d1 is 5, and F2 is 5. This gives 7 meters as distance x. To recap, Moment of force is the product of force and perpendicular distance from its point of action. Moment of force is mathematically expressed as moment of force is equal to force times distance. The principle of moment states that for an object to be in rotational equilibrium, the sum of clockwise moments must be equal to the sum of anticlockwise moments. The principle of moments is mathematically expressed as F1d1 is equal to F2d2. The applications of moment of force include wrenches and spanners, door handles, and steering wheels. The applications of principles of moment include balancing beams, bridge design, scales and balances, and crane operations. Now that you've unlocked the secret of moment of force, what about even more precise measurements? In the next video, we'll explore micrometer screw gauges because in physics, precision is everything. Stay tuned, stay curious.